This is what a typical electrical system looks like on a floor plan. A nightmare of receptacles and motors and panels and switchboards that's very difficult to understand. But this, the one-line diagram, is the master key that unlocks the entire system. If you want to design MEP electrical projects or install them as an electrician, then you don't just need to know what this is, you need to speak its language. In a previous video linked in the description below, I covered the basics of how a single line can represent multiple wires in a conduit or cable. Today we're going deeper. I'm going to show you how to take a commercial electrical distribution system and distill it down to its core. So here we have a symbol for a pad-mounted transformer, which for our building is the source of our power. Now, as you know, this transformer is served or fed by what we call upstream sources like dams, coal-fired power plants, nuclear plants, solar farms, wind farms, even battery storage systems, which actually feed this transformer. But for our purposes, this is the source of power for our building, and so this is where we will start with our one-line diagram. And we typically see a note that lets us know that this is the utility pad mount transformer, and you will typically see something about what voltage its secondary is. So in this case, we're talking about a medium-sized commercial building. So we have a 208Y/120 volt, 3-phase, 4-wire secondary. This is a standard commercial voltage setup in a 208 volt line-to-line, 120 volt line to neutral. So that lets us know what voltage and phase our building is running at. Now, extending down from this source, we have this line, which, per my previous video, actually represents multiple wires and even conduits or cables. So this feeder or service lateral runs from our source and it goes down to what's going to be our loads, or at least our distribution system that gets to our loads. And you will typically see some kind of an identifier on this feeder that says what it is, what size it is. In this case, we have a little note that says 200-4, shorthand for a 200 amp 4-wire feeder. And this tag would refer to some kind of a feeder schedule that says this is something like a 2.5-inch conduit with number 3/0 and such. So that's important to remember that not every little detail is going to be shown on this one-line diagram. It refers to other information as well. And then this next symbol is for a panel board, and it typically has an identifier on it. In this case, this is panel A. Simple as that. You'll see a wide variety of naming conventions in buildings, but this is simply ABC for now. So this here is about as simple as you can get for a single line, one-line diagram. Source, feeder, down to the panel. Now the next symbol we have is up here is a circuit breaker symbol. It will typically indicate the size of the trip rating in amps, 200 amps, and the number of poles that it controls. So in this case, we have a 200 amp, 3-pole circuit breaker. It will open or close all 3 hot legs of this feeder. I also want to remind you that this panel itself is not a load per se. It is part of the distribution system to get to the loads. The actual loads are coming off of individual circuit breakers in this panel, going through wires out to a motor or even a receptacle. Again, those are not shown on this diagram typically, unless it's like a large motor. So we just have to understand, again, that the rest of this electrical system may be shown on floor plans, for example. But I do want to introduce a very important concept in understanding one-line diagrams and distribution systems, and that is of power flow. Power flows from the source down to the load that is demanding that power. And it's good to understand which way that power does flow. Many one-line diagrams will have the source at the top, like I have here, and then loads down at the bottom. Sometimes you will see it other ways. Sometimes for a multi-story building, the source may be down at the bottom and the loads are up each story of the building. And we also realize that current flows through this system from the source down through the loads and then back. And in an alternating current system like this, it's going back and forth 60 times a second. So we can't really talk about current flow. We want to get into which way the power flows itself. That will greatly help when we start opening circuit breakers. So let me just show you with this highlight. We start at the source, power flows down through this breaker, down the wire, into the panel, and then it would actually go out to the loads. So this is the direction of the power flow from the source to the load. Keep this in mind. We will review this again as we get further into this one-line diagram. Now, if you're finding this information helpful, please just hit that little thumbs up like button to let other people know about it. Thank you. Now here you see a box around this breaker, which may indicate an enclosure. And then you'll see some kind of a label on this enclosure, such as service disconnect or main circuit breaker, something like that. Now, sometimes you might see additional panels on this one line, and you might see them tacked on to this panel A, as in this next diagram. Here we have a panel called A1 connected to panel A with a 200 amp 4-wire feeder. Now, how is this connected? It's not quite obvious from this diagram, so we'll typically see some kind of a little note here to let us know. So in this case, we see a little note that says feed through lugs. This is a feature that can be in a panel board that has lugs on the main buses of the panel board, such as in this photo, which lets us attach conductors to there and feed down into another panel if we need more circuit breakers on this 200 amp feeder. So just remember that the protection of this feeder, and both of these panels, is provided by this 200 amp circuit breaker. Now, in larger buildings, you may see multiple panels that can't be all served by this 200 amp breaker. So then you will see some kind of a distribution board, like this main distribution panel, or MDP. You will see now that we have increased our feed from the transformer to a 600 amp 4-wire feed, which serves a 600 amp 3-pole main circuit breaker. And this thick horizontal line represents a bus within this large panel. A bus is typically physical conductor, like a bus bar, that these circuit breakers attach to, similar to what's down in these other panel boards, but this is of course larger. And then this bus can have sub breakers like this 200 amp attached to it. And now this 600 amp distribution panel gives us room to attach more sub circuit breakers to feed more panels, like this additional 200 amp 3-pole breaker. From here we will extend wiring and another panel, just like this. So again, we have a feeder, 200 amp 4-wire, to panel B now. And we will keep seeing this for additional panels as needed, such as the next panel, panel C. Now this panel C happens to be a larger panel. It's a 400 amp breaker feeding a 400 amp feeder, which feeds panel C. Now, again, the information about panel C will be elsewhere in, for example, a panel schedule, which will give the details of the panel, like that it's 400 amp bus, it's rated for 208 volts, and maybe it has 42 circuit breakers in it. Now let's look again at this power flow idea. From the source, power flows down into this bus. Now, if all of these circuit breakers are closed, we will have power flowing down through there into these loads. We will have power flowing through here into these loads as well, and power flowing down here into those loads. And again, the direction of that power is down on our page. So it's important to realize if we open this circuit breaker and actually have a gap in the wiring, everything downstream would be off. This is upstream, up the page in this case. Downstream is down the page in this case, but we just need to remember that upstream is towards the source, downstream is toward the loads. If we close this breaker again, then everything's powered up. If we open this 200 amp breaker, what turns off? Well, the power flow would stop at that breaker and everything downstream from it would not be on. Now, another situation you can run into is you may see additional panels fed from these panels down here. We already looked at the feed-through lugs, which I shortened with FTL, but we could also have a circuit breaker in panel C, such as this. So a little circuit breaker as a subfeed, similar to what we did up here, but smaller, which can then feed another panel, such as this 100 amp feeder feeding a 100 amp panel C1. So this would be called a subfeed breaker rather than a feed through lugs. This panel is protected by a circuit breaker, again, which would be shown in the panel schedule. It would be 100 amps to protect this smaller panel. So there you have the basics of a medium-sized commercial building one-line diagram. In the next video in this series, we'll expand to show a 480 volt building with transformers and adding a generator and transfer switches. So stay tuned for that.